Good day, boys and girls. Welcome to Work on It Wednesdays. This is episode 5. Um, in episode 1, 2, 3, and 4, we started with this grade 11 question paper from the question paper book number 1, and we started with 2. We finished up until 2.4 in episode 4, and now today we're just going to look at at question 2.5 and 2.6. I just want to apologize for not having a video up last week. Last week should have been episode 5, but I had some problems with my internet connection, so then I couldn't upload the videos the whole week. I apologize for not having one last week, but we are back up and running and we can continue now from this week with Work on It Wednesdays. Right, so I have this, and they say evaluate without using a calculator. All right. Okay, now most of the exponential and root form questions, they will standard say that you are not allowed to use a calculator, and you must use your exponential laws and your root laws and all of that. That's what you're supposed to do there. Right. So the first thing I usually do is numbers. I'm going to take to prime factor form. And also something else is there's a law that says root of a times b equals root a root b, which just means if I have a product, there's also a root for division. If I have root a over b, I can take separate roots over them. Right, if I have a product or a quotient, I can take separate roots, which I cannot do if there is a plus or a minus between the a and the b, but as long as there's multiplication or division, I can take separate roots. So I'm going to split this 2 and the x16 into 2 separate roots. So I've got 10 root 2 root x to the power of 16 minus 2 root and 8. I'm going to make 2 to the power of 3 and x to the power of 16, and root 18, I'm going to 18 in prime factor form, divided by 2 is 9, divided by 3 is 3, divided by 3 is 2 times 3 squared. So I'm just going to split that in 2 and 3 squared. I also use this rule to split it into separate. 18 becomes 2 times 3 squared, but I immediately split it into separate roots, and then x to the power of 16 I also split under its own. Right, so from there on, how I calculate roots when working with powers, there's a law that says that the nth root of x to the power of m equals x to the power of m over n, right? Which basically just means if I have a fraction in my exponent, the top one is the exponent and the bottom one, the numerator is the exponent and the denominator is the root. So this is actually a root, or if I have, this should be a root 2, you know, I can just divide that exponent with 2. If I have a cube root, I can divide the exponent with 3. Alright, so I'm going to do that. I've got 10. This one I can't work out, so I'm just going to leave it root 2. And then this one, I can just divide that 16 by 2 becomes x root 8. And please be careful that you don't make this one a little bit too long, and halfway through the question you now not know whether this is under the root or not, and then you start taking the root of this x to the power of 8 again. Right, so when you have roots and after that you write something, make sure you don't put the root over, right? I actually prefer keeping the root, like put the x to the power of 8 here, keeping the root at the back, just so I don't put under anything else that comes after this accidentally underneath the root. You can swap them, so I'm going to do that. So I've got this one. This I can work out same, and it's going to be x to the power of 8. And this 2 to the power of 3, I'm just going to split in 2 squared and 2. And the reason that I do this, 2 squared times 2 is 2 to the power of 3, is because the 2 squared I can work out. This one I can't. Okay? Not without a calculator anyways. So 3 squared, the root of 3 squared is just 3. The root of x to the power of 16 is x to the power of 8. And this one I can't work out, so I'm just going to leave it like that. But you see, I just moved my roots, all of them, to the back. That's just because I don't want to make mistakes putting anything under the roots. Okay, and then this one I must still work out now. X, so the rest I'm going to just keep like that quickly. You cannot cancel this out because there's still a plus or minus there, right? This is now the square root of 2 squared is just 2. So this is 2x to the power of 8 times 2. So this becomes 4x to the power of 8. And that root 2 I can't work out. Now these are like terms, the whole thing. You can add roots like terms. So this is a like term. So 10 of this minus 4 of this becomes 6 of this over then 6 of 3 of x8 root 2, and then that can cancel, and 6 over 3 is simply 2. Yay. Okay, I love it when these root and exponential questions is so confusing and then it ends up in a 1 or a 2 or something like that. I actually love it. Right, let's quickly look at number 2.6. Number 2.6, there's a 2.6.1 and 2.6.2, but 2.6.2 is very fast and short. They give me this expression given a equals 3 to the power of n minus 4 over 6 to the power of n minus 2 to the power of n plus 2. Right. They give me this simplify a. So I want to simplify a. Now with exponentials, 90% of the time, the best thing to start with, if you don't know what to do, is make all of your base numbers prime factor form. So 6 is 2 times 3, so I'm going to split this 6 to the power of n in 2 to the power of n and 3 to the power of n. And then this one, this 2n plus 2, I'm going to split also in 2 to the power of n, 2 to the power of 2. If you are wondering if I can do that, let me just remind you of this law that says a to the power of x, a to the power of y. This is like your first exponential law always, equals this. Can you see I just use this law but backwards just to split this? And the reason that I split it, that's what I do when I have negatives in between exponential things. The reason I separate the 2 to the power of n and the 2 to the power of 2 is because there's a 2 to the power of n that I can take out. But if it's like that, I can't take it out, then what about that 2? So I split them, and then this 2 to the power of n, I can take out as a common factor there at the bottom, and I'm going to do that. So if I take out the tops, now just going to stay, I don't know what to do with that, I'm just going to leave it like that for now. I'm going to take at the bottom the 2 to the power of n out as a common factor, and then in this term that is left. Oh no, it should be an n. I don't know where I made that a 3. I split the 6 to the power of n into 2n and 3n. Okay, that should be an n. And if I take this one out in this term, this becomes, it's just that one that's left if I take this out. And then, can you see, if I just put brackets around this and this is the same, So I can take out the whole thing. You can't cancel if there's pluses and minuses unless the whole expression with pluses and minuses can cancel out. So that you can do here now. And then I'm left with 1 over 2 to the power of n. Okay, brilliant. And then 2.6.2 just says, hence determine the nth root of a. Okay, so I'm going to just determine the nth root of a, which this is a actually. So I've got the nth root of this. That's why they say hence determine, because I must actually use the stuff that I've worked out now in 2.6.1. And then that root laws that I had up in the previous question, if there's multiplication or division, I can take separate nth roots on both of the numbers. And the nth root of 1 is always 1, because like the square root of 1 is 1, the cube root of 1 is 1, the 4th, 5th, 6th, 7th, every root of 1 is always just 1. And the nth root of 2 to the power of n is 2. Okay, so there I'm done with 2.6.1 and 2.6.2. Have a very good week and see you next week again for Work on It Wednesdays.